In this photo you can see some parts laid out, ordered from Jameco, and other things that were not ordered from Jameco. But here are some resistors. Here are some more resistors. And here are some 240 ohm resistors. These are some of the voltage regulators. And here's a perf board that was used for some 5-volt regulator circuits for the meters. You to the side. Here is a little strip board piece with some chip holders on it. Took the chip holders off because I was going to use that board for the power supply for the meters. As it turns out, it would only work 1 meter at a time. But yeah, here's one board used for a meter. Then I'm attempting to take a picture of the schematic off the computer screen, and that black line from there puts it right on top of the schematic, only to meet Murphy's Law. Here's a custom wound transformer I did, because it's hard to find the right one on the internet. I had it wind on myself for the power supply. Here are remaining metal flanges from the transformer that wouldn't fit. Here's a test circuit on the breadboard to see if the voltmeter circuit would work, and it did. Here's another picture of the custom wound transformer. And here's the meter power supply circuit, which I was only able to do 1 power supply per meter. But as it turned out, that is a power supply circuit. There is a meter now, a meter circuit, the first meter circuit done. Then that's still the same thing. Components put in, and it's soldering job. Then it and the meter power supply. Then the other components for the next meter circuit was put on, and the underside. That's for the first volt and amp meter module. And a picture of it connected to that supply. And then there is another picture of the same. Some displays were put on so I could test it. There's a close-up of where the displays were put on to another board held with old ribbon cable. This stuff took hours. Many hours doing this stuff. Some more shots of that. Then the next module of 2 meters, complete with a date that it was finished putting onto the board. And getting started on the next perf board for the displays. Another shot of the display chip holders ready to be, for the displays, and the ribbon cable, some of the ribbon cable. The time of day that I'm doing that particular part, probably. Yeah, it's me working on it, looking down, me working on it, looking ahead. And another perf board with some of the wires started off. And more of the wires. I wonder if you can hear a lawnmower in the background. And current limit resistors for the current limiting circuit. Close up with that, I decided to put a whole bunch of resistors in parallel to get certain different values. There's a 2 meter circuits and a meter power supply circuit sitting on top. And then there's starting on the power supply circuit. A closer view showing the current limiting resistors. And then some layouts for cutting the holes into the panels. Another picture of that showing the layouts. And picture of the completed power supply ready to receive top cover. A close-up showing some of where the heat sinks and a lot of the voltage regulators and how everything's compressed together. That's the other meter power supplies right there. And then this is the very crude way that I held the display panels in place by using pieces of foam or pieces of cardboard from the component box. And there's the power supply operative and then now the top cover's been put on, and it's all set at 0. And there's a back with the heatsink visible and the plug-in for the power, and then a picture of a big circuit board. This circuit board has nothing to do with the power supply, but I imported it. Okay, I'm back again, and I just want to let you know that little slideshow, I guess, could have kind of been like a little intro to the whole thing. I'm going to be making a video series or whatever about the power supply project that I did. I took some video footage of whenever I got the transformer. It was a transformer that came out of an old stereo, and the stereo wasn't quite working, so I used the transformer. And I kept the primary, but I unwound the secondary and counted all the original windings and was able to put it into a formula to calculate how many turns I needed on the secondaries to get what I wanted was 24 volts out. So I did the turns and I wound the secondaries and came up with one of these secondaries being 24.8 or so volts, which was good, and the other one would be like 22.2 volts, and that was because I had to take off a few windings to get the metal plates to even fit back on the transformer. And they barely are fitting on there. It's a miracle that they do fit. But I have some video footage of winding. I have some video footage of taking the metal pieces off the original transformer, and I think I have some video footage of unwinding it, and then I have a little bit of footage of winding all of that. The video footage was done quite terribly, not good view or any of that. It's just a lot of stuff, complaining and whatnot. But I'm going to try to compile some videos in that kind of way. That will be good. And my power supply is complete, and luckily now the case is screwed together, because actually, if you didn't notice in the picture, the case was not quite on all the way. The top cover was not quite on all the way. It was really hard because the top cover didn't want to stay on all the way on its own because the thing was so packed in there that I was able to screw it down once I finally found some screws to hold the case together. And it's nice now. I'm able to power circuits and everything. Oh yeah, and since I've taken the pictures, later on, I made some circuits on the power supply, and I found out that there was this noise being put out in the power supply. This little noise. So I put some 0.1 microfarad capacitors to filter. I put those capacitors at the output terminals, and I also put them on all the output terminals for the meter power supplies on the inside, which are dual polarity power supplies, using a 7805 to give a 5 volt, and then they use ICL 7660 chips to generate a negative 5 volt supply. So each of the outputs, the plus to the ground and then the minus to the ground on the 5 volt power supplies that are to run the meters, each are filtered with a 0.1 microfarad capacitor. And it has greatly improved how things operate, because now, actually I put the capacitors on the voltmeter meters, not the ammeters, and it greatly improved and filtered out that noise that was before causing a problem in a circuit. But after I put the capacitors in, the noise was filtered out, and the problem that I had in the circuit that I built no longer was there. So we're good. I'm sure you noticed the stereo separation in this video. It's quite something. Using some very high quality microphones here. That lawnmower's still going. But anyway, I'm getting off track. So yeah, those pictures I obviously made while I was working on it, and it's built now. And the sound, that sound this, it's me turning the power supply on and off. So yeah, now let's I guess let's make some video of this. The project here is to rewind some secondaries for a power transformer to be used in a homemade power supply. Make sure it hangs off enough that the thing can come out freely. Have to hang off the table. Okay. That part's fully loosened, and sure enough it is. It's now out like EI. About 50 minutes it takes to do. It's a while. Almost an hour. But there we go. Just look at the pile of all these. I mean, here's our core, or coils.